attention. We still have 2 units to get through. Okay? Whoa, whoa, whoa. Was that a challenge?
Yeah, that's a challenge.
I don't think we need to try. I think we're good.
No, we believe you can, so I don't think we need to.
Yeah, I think
Wait, late.
I think I've learned what I needed to this year.
I don't. Okay, let's go. Alrighty, so it is 5:13 today. This is 4th period. This is going to be SM2H unit 11.1. It's challenging.
My grade is already separated from unit 9. I haven't got a good grade here.
Sorry.
How many like sub-units?
I think there's 4. Alrighty, now listen up. We are going to. We have. Let me now that you.
It's called probability.
There is. Dang it. There is 4. Okay. Now, we are probably going to do actually 11.1 and 11.2 today. So we'll probably just squeeze this into 2 days, but we'll see how it goes. Okay. Alrighty. Now, if I just use the word probability, what comes to mind? Okay, gambling, dice,
Poker.
fractions, what? Ratios, okay. There's an O word that usually comes up there. An O word. They use it in Vegas a lot. Nobody's ever heard the term odds? Oh, yeah, that's the O word, not Ogden. Okay, odds. Now, probability is really,
Doesn't that say probability? Yeah, that's what I was doing.
Yeah, there's another B in there.
There is a B. It's the 4th letter.
No, 2 B's. Oh my gosh, B. I thought we meant.
I see a B and an I, David.
No, that.
Okay. One time is an accident. Twice is a
Oh, just shut up. You knew what I meant. So, to me, probability is likeliness. Do you understand what I mean when I say that?
Yes.
It's how likely something is to happen. Like, for example, would be something like this. So let me write it this way. So I said, if you do not do your homework, you will not pass this class. Okay, that's a statement, right? And then I say, okay, what is the probability damn it, I did it again. Yeah, I don't know what's going on here. Probability. Is that better, David? Yeah, you're welcome. What is the probability that David, just because I had to use somebody's name, passes this class if he doesn't do his homework?
What your statement is, if he doesn't, he won't.
No, I just told you. If you do not, you will not, right?
0%.
So the answer would be 0% probability. It's not going to happen. It's not. Okay?
So you still won't pass.
What is the probability that David passes this class if he doesn't do his homework? That probability is 0. Okay? Now, pretty much everything in life can be traced back to some kind of probability. You know what I'm saying? It's like, an example is, what is the probability that I will be on time for work tomorrow? 100%. Based on what?
Yeah, that's not right. Like, there's so many other things that can happen.
Exactly. So is it really 100%? No. Okay, so that's what you got to do. You got to look at it from a perspective of there's a lot more that goes into me being on time than just me dragging my butt out of bed early, right? We're going to get into that, just not today. Okay? Now, everything we're going to do looks at it from a specific perspective. So, for example, let's say I roll 2 die. Okay? What is the probability that I roll a 7?
Oh, wait, shoot, never mind.
1 out of 18.
30%.
No, when you add it up together.
Okay, so now, okay, the probability that I roll a 7 is 0. Because there's not a what? There's not a 7. But if I roll a sum of 7, now, right? Yeah, so now I got to look at it. How many possibilities are there? How many total outcomes do I have? There's 36 outcomes. How did I get 36 outcomes? Because each one has 6 sides, right? So 6 times 6 gives me my 36 outcomes, right? Then I got to go back and I got to say, okay, what are my potential 7 outcomes?
6 and 1, 3 and 4, 2 and 5. 2 and 5. And you can do both.
Exactly. So I got to look at both sides, right? So I would literally list them. And I would say I got a 1 and a 6, or I could really have a 6 and a 1, right? Or I've got a 5 and a 2, or a 2 and a 5. I've got a 3 and a 4, or a 4 and a 3. Is there any other sums that come to 7? So then it would be 6 out of 36. I do the math. What is my probability? 1/6 or 17%. I would probably go 1 decimal here. So I think this works out to be 16.5%. I would probably go there just because. Oh, yeah, 0.66. So 0.7, right? You're right. Okay. Now, make sure that you think through this critically. Do you know what I'm saying? It's like a Coca-Cola freestyle machine. Okay? Who knows what I'm talking about?
Like the ones at Wendy's?
Like the ones I haven't been to Wendy's in recent memory. I'm thinking the movies downtown. Yeah. I love me some lime mellow yellow, right? But when you think about that, how many potential drink combinations are there? Yeah, there's thousands. There's probably millions. But if you narrowed it down, there's probably maybe really 200 or 300 is all. If I look at doing the whole pop, right? You know, I could go with Coke and these 17 flavors, or I could go with mellow yellow, and I think there's 8 at the bottom. You know, so there's all those different combinations. What you've got to do is you've got to really look at it through a very critical lens and look at all the potential possibilities, right? So let's say I did this. Now, How do I want to do this? Okay. Let's say, suppose you roll 2 dice. 2 die, I think. Die, what?
I just like, isn't there like a higher probability? Like if my favorite soda is Sprite, isn't there not like a,
There
not
is
the
a higher
same probability? It's like,
because it's your favorite, isn't it?
What do you mean?
Like if I pick Sprite like every time, it probably has a higher probability of me picking Sprite this next time.
Yeah, no, and that's okay, but so you got to understand that that's a conditional. It's not a true random statement. It's just like when I said the probability that I'm going to be here tomorrow on time, I think is 100% based upon my track record, right? But if I change that and I'm flipping a coin, let's say I flip that coin 1,000 times, and every time that coin comes up heads, every time, what is the probability the next time I flip it, it comes up heads? It's still only 50%, because that's a truly random. Does that make sense? Other kinds of probabilities are based upon prior. Do you see what I'm saying? So you got to look at them differently. Okay. So let's say let's suppose I roll 2 die, right? Yo.
Dice is 2.
Well, that's what I was trying to remember. Die is 1.
Yeah.
2 dice. I'm not an English guy. Okay. I rolled 2 dice, and I get. Oh my hell! I cannot write for some reason. Yeah, I get a sum that is not 7. Yeah, I just take what is left over. But how do I really do that? Does anybody know?
The same way we did
Well, how many
everything that
times do you
isn't
get
7.
7? And then
Yeah.
Okay. It's actually called the complement, because they would add up to 100. So what you would do is if I wanted the probability of A, okay, I would take the probability of not A. These two have to be what? Equal to 100, because I've got to take them all into account, right? So my probability of rolling a 7 was 1 out of 6. My probability of not rolling a 7 has got to be whatever is left over, and that's going to be 5 out of 6. Okay? There's a lot of different ways, and I don't care. I would probably, knowing you guys are going to turn all these into decimals, so I would probably go that extra step, and I would probably say let's go at least 1 decimal place, just so we're all on the same page there. Does that make sense? Okay? Now, the next thing we need to talk about is what?
Nothing. That's kind of making fun of
Okay, so who knows what a two-way table is? Let me know. Yo.
Isn't it like where you put the numbers on one side and then put the numbers on the
Like the punch.
Okay, that's a. No,
something else. I don't remember.
that's called a stem and leaf.
Oh yeah.
Yeah, where you put the first number and then you put the. Is that what you're talking about?
No, I mean like a square.
Oh, yeah, okay, yeah, it's exactly what we're talking about, right? Yeah, so, okay, so two-way tables are going to look like this, okay? And let's see if we can just make one up really quick. It's called a two-way table, right? And it would be something like, let's do boys, let's do girls, let's do glasses.
Oh, I like
I forgot my total down here, sorry. I got to have another thing. Okay? Now, no matter what, he's quarantined. We're at 27, right? So no matter what, I have to total students have to be what? 27. Butler doesn't count, right? So boys and girls have to add up to be 27. No matter what, that's what we're going to come out with, right? Is 27, okay? So then we got to look at, okay, say how many girls are in this class?
Decent amount.
8? Wow, I never realized that it was that bad. 8? So girls is 8, right? Do I even have to count the boys? No, it's going to be 19 no matter what, because I have to add up, right? Now, then we'll say, okay, how many of you? What? Oh, I appreciate you giving me permission. Okay, now, so how many of you girls wear glasses? You do?
Yeah, I wear contacts usually, but yeah.
So you have, so only 1, 2? That's it? So girls and glasses would be 2, right? Now, do we have to do this math? Or do we have, no, just do the math at 6, right? How many boys wear glasses?
Not anymore.
Who used to? Weston? What, did you get contacts? Nice. So we're 0. That kind of ruins it, but whatever. So that's 19, right? Glasses is 2. Not glasses is 25, right? Now, here's the question. So there's my two-way table. Now they're going to kind of go back to what you were talking about. We're going to base things based off this table. So if I said, suppose I selected 1 boy from this class. What is the probability that he wears glasses?
0%.
Yeah, it is going to be 0 out of 19 because I'm only...
It's just upside down.
Okay, now I'm concerned.
Well, that makes 2 of us. 0 out of 19 for 0%, right? So now if I said, what is the probability that I select a girl and she doesn't wear glasses?
75%.
Now it's got to be 6 out of, you got to make sure you're looking at the right section. Because I said I selected a girl, so now I'm limited to just the girls. And she didn't wear glasses, it's that out of that. And that would be 75%. We understanding how this works? Okay, they're really not that hard. Now, let's say I did this. Let's say
Wait, but what if it's like, what's the probability that a kid in the class wears glasses and
Okay, now say that again.
So it's like, what's the probability that a kid in the class wears glasses and isn't a girl?
Just 2 out of 20.
Same thing. Yeah, it'd be 2 out of, then it'd be 2 out of 27 because now I'm putting that group together. Does that make sense? And that's why you got to really look at it and say, okay, what are they asking me to find to make sure I go to that right box, if you will, and then say, is this out of just the girls, is this out of just the boys, or is it out of everyone? Yes?
Well, I was going to say, wouldn't you have to have the probability of it being glasses and of it being girls?
Now, if they did a compound probability, yes. So that would be something like, what is the probability that I draw 1 student, and it is a girl, and she wears glasses? Now, with a two-way table, you just pick that section.
Okay.
If they gave you percentages, then you would have to go and do that math.
And how would I do that? Like a boss?
I'm going to be honest, not right now, but I'll teach you because it will come back to bite us in the butt. So watch. You got to understand there's 2 kinds of probabilities they're going to do. They're what's called ands and ors. Union and intersections. They go P and B, and let's go P union B. This is and. This is or. And you multiply the probabilities. In or you add the probabilities. Does that make sense? So, but that's when they give you values like wow. An instance I remember is probably the World Series, probably early 90s. Yankees are playing somebody, right? And the Yankees bat all the way through the order. Right? All 9 batters get a hit. And the commentators are just like freaking out, right? And I'm like, well, I was young. I'm like, I don't understand why that's such a big deal, right? And then I became a teacher, and I'm like, damn. Well, think about that. So let's say I've got 9 batters. Hey, Wadsworth, you on here? Bummer, he's a baseball guy, right?
Yeah.
Yeah, he'd help. We don't have another baseball guy in here, do we?
Wait, this is
Did you start slow pitch softball?
What?
Slow pitch softball? We could change it, then I get it.
Whatever. Okay, Riley. Let's pretend they're softball players, right? Do you guys track batting average?
Yeah.
Okay, so any ideas what your leadoff hitter hits?
It's like 389.
389.
It's not good.
389. That's a hell of a batting average. You hit 389 in the major leagues, you're making 20 mil a year.
That's good. Maybe I should hit
Okay? Your second batter is usually not quite as well. So we're talking probably 360. Third batter's even a little lower. Let's say 325. Now your cleanup
fourth hits dingers.
hits dingers, hits for power, but not for average. So we're maybe a 290 guy here, right? And then from there it goes pretty much downhill, right? If you're in the, I'm trying to remember which league has their pitchers bat. AL?
NL does.
NL does?
NL does, AL does.
Okay, so we're in the NL here, and I got my pitcher up there, and he's an 095 hitter. He sucks. But he throws 100 miles an hour, so it's okay, right? So this is going to be like a 285, a 270, a 265, and a 250 hitter. This guy's probably like your, I don't know, catcher. It's still pretty good. But now, so here's my question. Why were the commentators so excited that the Yankees hit through the order? Exactly, because it's an and problem, which means that the first batter got a hit, and the second, and the third, and the fourth. You're going to take all those values and multiply them. Do it. Give me an answer. Yeah. You're going to times all those values together. Well, you don't even have a calculator out.
Oh, I did 3.2.
Do it. Everybody do it.
Dude, if you mess up once, you mess up the entire
Yeah, it does screw you up.
I have them.
You have them all?
It's to the negative fifth.
Yeah.
So let me hurry and redo this.
What do you got, Carson?
About like 6.39, and then it just keeps going on to the
Times 10 to the -6.
Why does this hurt my brain?
Shh. Now listen. You need to understand what this is. Who knows what this is?
It's scientific notation.
Scientific notation, right? Now, if it's negative, I'm going to move it left. So I'm going to go moving left 6 spots, right?
Jeez.
So,
So that's just your average.
It kind of is.
so that's tenths, hundred thousandths, 10,000, hundred thousandths, millions. You've got 6.4 out of a million probability. Yeah.
Actually, it's the -13 because it had the -6 at the end of it, but it goes on for about like 9 or so 8.
Well, all that matters is where that decimal's at.
Oh, it is.
Yep.
Okay.
I'm moving it left 6.
Okay, that makes sense. Okay.
So you could bat tens, 100,000. So 10 million. So 64 out of 10 million times. If you hit 10 million through the order 10 million times, you would be successful. 64 is all.
Pretty good ratio.
Which tells you how big of a feat that was. Now, if I change that, and I simply said, let's go just through the first 4 batters. But now I want the probability that any of them get a hit. Now it's an or problem. So now all I need is my first hitter to get a hit, or my second, or my third, or my fourth. Now I'm going to take those and add them up, right? So now, what is it?
1.364.
1.364. So I have a over a 100% chance that one of those first four are going to get a hit, which is why they hit 1 through 4.
Which is why no hitters are so good.
Which is why Nolan Ryan was the greatest pitcher to ever play the game. Because he threw 7 of them.
Dang.
Yeah, he could throw. Does that... Are we kind of starting to see how this works together? Yeah? So, now... that's enough of that. All right, now... We're going to go over what's called a Venn diagram. Anybody know what a Venn diagram is?
Like when you compare something? Like,
It is.
when you compare stuff? Oh,
Yes.
So on the 1 through 4, there's still a good majority of chance on every one that they'll miss.
But the key is that it is an
Or.
or statement.
So even though that all 4 of them could miss, that's a possibility.
Yep.
It's still technically
Yep.
100%.
Yep.
So how do
Because
write
you
an answer?
add instead of you multiply.
And how is it 130% that one of them's going to hit it if one of them doesn't hit it every time?
But like you could have all 4 of those people miss it.
You could.
But that's.
But the likelihood of that happening is
Negative 70%.
really small.
How
It
is
is.
100% then?
What?
I just don't get how it's a 100% chance that 1 out of 4 is.
Okay, so let me see how I can explain that. So if I were to take
Well, isn't it just like you took how good they were?
because it goes back to exactly. It goes back to the conversation we were having earlier. It is all based on prior experience, right? So it's just like you said, the next time you go to a drink machine, you're going to get Sprite. Does that make sense? This is based upon how successful they have been over and over and over again. Does that make sense?
It's not like exact.
Exactly.
But how
Yeah.
can it be more than 100%?
Because that's what the math does. Yeah, that's just the value.
So
Yeah.
So like that last part, like your 4th batter could have been a 0.9, and so you'd have like a ridiculously
Yeah.
higher.
Yeah.
That doesn't matter.
No, doesn't matter at all. No. All you're looking at, and what you'll end up doing is you'll end up being hopefully a more critical thinker when you look at this and say, okay, I see that number, and what that really means is 136.4% chance of happening, which is really pretty much a what? That's a guarantee. That's a Joe Namath. We will win the Super Bowl. None of you guys are old enough to even know who that is. Remember, he guaranteed. Yeah, he guaranteed a win. Right? You never, ever, ever do that. It's just bad karma. What?
Well, he won. So.
Well, I know, but he's probably one of the few in history that have won. Right? So what you guys need to understand is you've got to look at probabilities in the framework they're in. Is this a probability based upon prior experience, or is this a truly random probability? If it was truly random, you're right. Very seldom is it ever going to be 100%. This is based upon prior knowledge. Based upon that prior knowledge, it's going to happen. I'm going to be on time in the morning. That's just the way it is. You know what I'm saying?
Yeah.
Yeah, even with the detour, I'm going to be here.
That's crazy though, because like all of those batting averages are less than like.
Exactly. But you got to remember, because it is an or they compound on top of each other. Does that make sense? But if it was an and, now I need all 4 of them to hit, you're going to see that change dramatically. That's what you're thinking. Does that make sense? We all? Yeah.
But I don't know where I was going.
You all right, Ethan? Or
Sorry, it's coming back.
oh, okay.
Wait, did you say it had to be in 1 inning or no?
No, it'd have to be all in a row. Yeah. We're
Like
number 1's getting up, getting a hit. Number 2's getting up. That's if it's an and. If it's an or, I just need one of them.
What game was
If
this?
it wasn't or, and
It was a World Series. Yeah, it was crazy.
Oh, it's without getting it out.
Yeah, without getting it out.
Oh, okay.
No, they're actually getting a hit because this is their batting average.
How would you do it if there's like if you went through 2 rotations?
You would times them all together again, and you'd get in.
Can't you just square that number? Because it's that number times that number again.
Oh, yeah, you could.
Okay.
It'd be really small. Yeah, pretty much non-existent. Yeah.
Jeez, that would be ridiculous.
Alrighty, Venn diagrams. Who knows anything about a Venn diagram? What? You do?
Yeah.
For what?
When you research.
Oh, yeah, compare and contrast. Well, we ain't talking English here. There's a reason I teach math and chemistry. Literally,
Yeah, we know.
yeah. Really? That was pretty good. That was pretty good. Yeah. She gets an F. All right. So, who can tell me? Who can tell me what goes on here? Yeah.
One side is like a characteristic one thing has, the other is what they have alone, and then together is what they both have.
Okay. So, can we come up with one of these for us? Okay. Similar. Probably. Well, let's try, David. Why don't you lead the charge? What do you want to do? Well, let's do an easy one. Let's do this one. Let's do boys, simply because it's a bigger pool. We'll go boys. We'll go blondes. Right? Okay, boys and blonde. That way the numbers are smaller. Okay? Now, so what's going to go where?
All the boys' names would go.
So all the boys' names would go on the left. How many's that? What did we decide? 19, right? So I'm just going to put 19 over here.
All of the boys with blonde hair go in the center.
Yeah, all the boys with blonde hair go here, right? Do you see what I'm saying? So this would be Christian, you know what I'm saying? How many do we got? Let's just do it by numbers. We got how many? So we got 1, count them up.
3, 4.
4?
I think.
Which one? They both look blonde to me.
6, 7.
Well,
I got 7.
7?
I got 7 too.
You're blonde. Did you count?
I'm not blonde.
Yeah, you are.
Yeah, you are.
I'm brown.
They're smoking crack. Yeah, you're not a blonde.
I'm definitely.
So we'll go with 6. Okay? So if that's 16, what goes out here?
13.
13, right?
And can you put blonde girl?
Now, okay, so we didn't specify that, but here would be where the,
Blonde girl.
because, no,
Where
The extra blonde boys.
All the boys are boys.
Blonde girl.
exactly, this would be the girl blondes, right? Because they still fall into the blonde category, which is,
You didn't specify if it was a girl blonde or just a blonde.
yeah, that's why.
That's why I can't.
So it's boy and girl.
But so would it be girl boy and girl blonde?
No, because the boy blondes are right there.
Oh.
it has to be just the girl blonde.
Oh.
Yeah, just the girl
Because the
blonde.
side on the left has to be
Do you see what I'm saying? This is where they overlap.
I can't tell.
So, it doesn't matter. Whatever it is, let's
Me
say,
and Charlie are blonde.
So.
That's about it. Just me and Charlie.
Did you just have highlights? Yeah. Does that count? Does that count?
I think she's blonde.
what do you got, Charlie? What?
Wait, number? I don't know.
Just me and Charlie?
So 2,
Sure.
right?
Wait, is it I can't tell.
I think they're brown.
Blonde.
Or at least
I say that's
tan.
blonde.
I
I
say
said
blonde.
that goes blonde
And
too.
Braden's blonde. Oh,
I
wow.
think I am.
Okay.
Blonde.
I think so.
Oh, there, boss.
What's so funny, Boston?
Consider blonde.
Yeah.
Now,
Charlie.
now here's my question. If I still want to account for all my students in this class, where would I put everybody else?
You can put the girls who aren't blonde on the outside. It's just on the outside.
Yeah, so, but I got to understand, I still have to account for everybody. So that's going to be what? 8? No, but it's got to be out here I got to account for everybody that's left, right? So this is only 19, 20, 21, 6. That's where that'd
I
go.
guess I 4.
Yeah, you said 4. That's what.
There's 6
Yeah.
girls in the class, that's why.
Whatever. We get the idea. That's all that matters. Do we get the idea or not?
Yeah.
Yes.
Like, you know there's 8 girls and they won't go in either of them, and there's only 2 blonde girls.
Yeah. She just kept saying 4.
I kept saying
She meant 6, but she kept saying 4, so I was a little baffled by that. And then something was funny over here, and, you know, we got sidetracked a little bit. But that's exactly what I would have done. I would have said, hey, what's left? Well, we already did the two-way table, right? So we knew our number was 8. Subtracted off. Does that make sense?
Yeah.
Now, what they're going to do, they're going to present several of these to you. I don't know. I think they're really easy. But there is one thing I want to talk about, and that is when they do this. When they do how do I say this? They do a union problem. Like if they give you 3, they do 3 of these, right? So I've got a group here, I got a group here, I got a group here, but then I've got something that belongs in all 3 groups, right? Okay? And then they do something like this, A union B or A and B. Okay? Now A union B is everything in those 2 groups.
But there's 3.
But we're talking just A and B right now. Okay? Now if I did want to know A, but that would have been A and B is just where they what?
Intersect.
Yeah, just where they intersect.
So it'd be that the middle top.
Yeah, it would be A and B, it'd be right, this area right. Well, this whole area. Yeah, it'd be that whole area, right? But if I did A and B and C, now it's just that little area right there. So just make sure you look at these, you know, in the right way. I don't think these first two sections are very complicated, as long as I can look at the picture and understand what it's asking. What'd you say, Charlie? What did you say? I can't talk unless I pull my ass down, Charlie. What'd you say?
I said probably.
I asked if you were doing 2 assignments, and she said probably because you said 2 sections.
I was just being smart.
I'd say the probability of that's 100%.
Actually, Anna.
He is. Look at that's one.
No, blonde is a shot.
A lot of people. I'm dead in black.
Get busy. We're done. I was not done, but they are done, so whatever.
I'm in 2 math classes right now, so I always go to quick and long math.